Good morning, everyone, and today we will report about the basic concepts of hypothesis, Lesson 5, Test of Hypothesis. Introduction. One of the major processes in statistical inference is to determine how likely a claim is or whether a particular result is statistically significant. Both of these questions are answered through a hypothesis test. A hypothesis test in statistics is an explanation of a situation. The result of the hypothesis test is interesting because the answer is not the focus of the process. Rather, we are interested in the argument that proves the result. Two main approaches to doing a hypothesis test. In our discussion, we shall focus on the approach most commonly the p-value approach. Statistical hypothesis, a conjecture or supposition about a population parameter. A statement about the value of a population parameter developed for the purpose of testing. A statistical test that is used to determine whether there is enough evidence in a sample data. It is a statement or tentative assertion which aims to explain the facts about a certain phenomenon. A method of statistical inference used to decide whether the data at hand sufficiently support a particular hypothesis. This statistical hypothesis testing is a method of making decisions about a population based on a sample data. So here are the two kinds of statistical hypotheses. Null hypothesis is a statement saying that there is no significant difference between population parameter and the value that is being claimed. It is also the current accepted value that majority of people holds to be true. Null hypothesis is denoted by H sub 0. Next is alternative hypothesis. Is a statement saying that there is a significant difference between the population parameter and the value that is being claimed. Alternative hypothesis is what researchers are trying to prove in order to disapprove the null hypothesis. If the alternative hypothesis fails to prove, it means that the null hypothesis is likely to be correct. Alternative hypothesis is denoted by either H sub 1 or H sub A. So now, let's proceed to the examples. For number 1, the average monthly income of Filipino families who belong to low-income bracket is 8,000 pesos. For our H sub 0, the expected population mean of the monthly income of families is an average of 80,000 pesos. And for our H sub A, the researchers believe this to be different, so he believes that the average income is not equal to 8,000 pesos. For the next example, the teachers in a school believe that at least 80% of students will complete high school. A student disagrees with this value and decides to conduct a test. State the null and alternative hypothesis. For our H sub 0, the teacher believes that 80% of students will complete high school, and because the given mean is in percentage, it will be proportion. So at least 80 means it could be 80% or more, so the proportion is going to be greater than or equal to 0.80, which is the decimal equivalent of 80%. For our H sub A, the students disagree with this value. It means that the students believe it is less than 80%, so for our alternative hypothesis, the proportion is gonna be less than 0.80.
So there are two types of hypothesis tests. The two types are two-tailed test and one-tailed test. So for the two-tailed test, also known as non-directional hypothesis, the standard test of significance to determine if there is a relationship between variables in either direction. Two-tailed tests do this by dividing the 1.05 into and putting half on each side of the bell curve. So we will do this to find if there are a relationship in the right side and the left side of the normal distribution. So the next type of test is the one-tailed test or the directional hypothesis. It is a test of significance to determine if there is a relationship between the variables in one direction. It is useful if you have a good idea, usually based on your knowledge of the subject, that there is going to be a directional difference between the variables. So there are two directions. It is the right and the left. So how can we figure out if we were to use one tail test or two tail test? So for the right tail test, if the alternative hypothesis is positive, if it is uh, higher than the null hypothesis, we are going to use the right tail test. If 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 the statement is saying something like more than or the population mean is bigger than that, it will be right tail test. So for the left tail test, it will the population mean will be negative because it is lower than the null hypothesis. So for the two tail test, it could be in other side as I have said a while ago. So the alternative uh, alternative hypothesis will be in the right side or the left side. So for our example one, a company manufactures potato chips and the average mass of each potato chip is 100 grams. An employee believes that the average mass is different. So for the null hypothesis, it is the first claim says that the potato chip, the average mass of the potato chip is equal to 100 grams. So our null hypothesis will be population mean is equal to 100 grams. So the second claim says that it is different from the original claim. So our alternative hypothesis will be population mean is not equal to 100 grams. So with this, the test that we are going to use will be two-tailed test. Next. For example number two, according to a university in Manila, 51% of its students own a smartphone. A research a researcher surveyed a random sample of 300 university students in a particular university. The researcher found out that more than 51% of its students own a smartphone. So for the null hypothesis, it is said that it is equal to 51. So the null hypothesis will be population mean is equal to 51%. And the other claim says that it is more than 51%. So our alternative hypothesis will be population mean is greater than 51%. With the alternative hypothesis, our hypothesis is greater than 51%, meaning that the hypothesis test that we will going to be using is a right tail test. And for the next example, a group of researchers would like to conduct a survey to see whether the average user spends 40 minutes per day on a specific social media platform. So, so for the null hypothesis, it is said that the user spends 40 minutes per day on average. So our null hypothesis will be population mean is equal to 40 minutes. And to contradict the null hypothesis, the alternative hypothesis will become population mean is not equal to 40 minutes. So since it is saying that it is equal and not equal, the hypothesis test that we will going to be using is a two-tailed test.
The types of error. Type 1 error. Type 1 error occurs when we reject the null hypothesis when it is true. It is also called alpha error. Type 2 error. Type 2 error occurs when we accept the null hypothesis when it is false. It is also called beta error. We are dealing with the null hypothesis here in type 1 and type 2. But always remember, you are going to deal with the type 1 error if you have the null hypothesis, if you reject this one, even if it is true. But if the null hypothesis is being accepted, even it is false, automatic, that will be a type 2 error. For example, in type 1, you said you are studying well, but truth is you are not. But if you are accepting the false, that is type 2. For example, you started to think to steal your classmate's ball pen, even you know from the first place that it is wrong, but you still do it. Next. Example number 1. A group of friends insists that they are drinking 8 glasses of water a day. In fact, 50% doesn't drink 8 glasses of water a day. What type of error? Type 1 error because the null hypothesis is being rejected even if the null hypothesis regards to the group of friends is true and fails to deny it. Next, please. Example number 2. A company claims that they give 100% of the salary to their employees, but they are just sending 70% of the salary to their employees. What type of error? I can say type 2 error because the null hypothesis is being accepted even if the null hypothesis is false and the company fails to reject it.
So now let's proceed to the level of significance. The probability of committing type 1 error is called level of significance. The choice for the value of the significance level is determined by the researcher. This depends on the risk or degree of confidence the researcher is willing to make in committing type error. The level of significance is denoted by the Greek letter alpha. The value tells us the probability of making an error in rejecting the null hypothesis it is actually true. So the two commonly used level of significance are 0.05 and 0.01. So how to calculate a level of significance for one and two-tailed tests? For one-tailed test, for example, if you want to be 95% confident that your analysis is correct, the alpha level would be 1 or 100% minus 0.95 or 95% is equal to 5%. Or if you want to be 98% confident that your analysis is correct, the alpha level will be 1 minus 0.98 is equals to 2%. Or if you want to be 90% confident that your analysis is correct, the alpha level would be 100% minus 90% is equal to 10%. So for our two-tailed test, for two-tailed test, divide the alpha level by 2. In this example, the two-tailed alpha would be 5% divided by 2% is equal to 2.5%, or 2% divided by 2% equals to 1%, or 10% divided by 2% equals to 5%. So why is an alpha level of 0.05 and 0.01 is commonly used? Seeing as the alpha level is the probability of making a type 1 error, it seems to make sense that we make this area as tiny as possible. If we set the alpha level at 10%, then there is a large chance that we might incorrectly reject the null hypothesis, while an alpha level of 1% would make the area tiny. So why not use a tiny area instead of the standard 5%? The smaller the alpha level, the smaller the area where you would reject the null hypothesis. If you have a tiny area, there's more of a chance that you will not reject the null, when in fact you should. This is a type 2 error. In other words, the more you try and avoid the type 1 error, the more likely a type 2 error could creep in. Scientists have found that an alpha level of 5% is a good balance between these two issues. And that's all for our lesson. Thank you for listening.